Okay. So previously, are you okay with your book? I think. Okay. Good. Okay. Previously, remember we learned about ionic bonds. Okay. And then we learned things like if it's magnesium with chlorine. So what we did is we write down the electron arrangement and then it became Mg2 plus, right? And then Cl, we write down the electron arrangement and then it became Cl negative, right? And so we know what is the ratio of magnesium to chlorine. Magnesium releases two electrons and each chlorine receives one. So the ratio has to be 1 to 2, right now. So the ratio of magnesium to chlorine is 1 to 2. And so then it becomes MgCl2. Okay. Okay. So today I'm going to teach you an easier way. No need to do all this. That means no need to write down the formula and da 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 da. We just know. Okay. So what we do is, can you help me check? So it's like this. Just have to make it push it in a bit more. Mm. Last time they used to have one which has a hook inside, which they just like hook it in. I don't know why they don't have that. Because if I put it two in, then you might not be able to turn the pages. Oh. Can you try and see? I think it's tight enough. All right. So what we do is we don't need to do this method anymore. We do something where we just need to remember the ions and then we just swap. So for example, you already know that Mg is 2 plus and you already know that Cl is 1 negative. All you need to do is swap this number. Okay? So this is 2 positive, 2 put it down here. This is 1, you put 1 down here. So it becomes MgCl2. Okay? Okay. All right. Have you learned this in school before? That's all. Okay. So, but what you need to know now is you need to remember all the positive ions. Okay. So it's quite a long list. Okay. I'm going to teach you an easier way. Okay. These are all everything of that is available. I want to teach you a slightly easier way to remember some of it. Okay. So the first thing we remember is positive ions are also known as cation ions. Okay. So it's easy if we just go by group. Everybody in group 1 is positive 1. So for example, potassium, sodium, and of course lithium. Everybody in group 2 is positive 2. For example, magnesium and calcium. Everybody in group 3 is positive 3. So for example, aluminium. And then it comes to transition metal. So who is in the transition metal? So for example, zinc is always 2 plus. Here. Lead is always 2 plus. However, there is actually something called lead 2 and lead 4. So can you please put here lead 2? Because there is such thing as lead 4. So we call it lead 4 ions. Okay. This is page 91. You understand? So lead 4, and then iron, there is iron 2 and iron 3. So what you need to notice is these are all transition metals. Silver, copper 2. There's copper 2 because there's copper 1. Okay? There is copper 2 ion because there is such thing as a copper 1 ion. Cu plus. Like that. Okay? Uh, zinc, lead 2, iron 2, iron 3. These are all transition metals. Okay? Another one that are non-metals, there's only two positive non-metals that you need to remember. Hydrogen ion and ammonium ion. Okay? So for negative is very easy. So negative is like this. We start with group 7, which will give us negative 1. Fluoride, bromide, fluoride, iodide. Okay? These are all group 7. But you notice the name? It's not chlorine. It's chloride, bromide, iodide, fluoride. Okay? And then if it's group 6, it's oxide and sulfide. And then who is group 5? Can you remember group 5? You have phosphide and nitride. Okay? Can you understand? All right. Now, this is when it's just the element sulfide oxide. Now what we do is we mix them up together. So if you look at this, nitrate. NO3 negative one is nitrate. N3 negative is nitride. So if it's just N3 negative is nitride, right? But if it's NO3 1 negative is nitrate. One more thing, if it's NO2 1 negative is nitrite. So there's tried, trade, tried. Why is it confusing? I don't know. I'm not the one who invented this, okay? Let's look at the sulfur one. S2 negative is sulfide, right? S2 negative sulfide. SO4 2 negative is sulfate. Okay, so sulfide, sulfate. But SO3 2 negative is sulfide. Can you answer? Okay, now OH OH negative is hydroxide. OH negative is hydroxide. Okay, can? CO3, 2 negative is carbonate. Okay, one last one I'm going to show you is HCO3, 1 negative. This is called bicarbonate, or it has another name called hydrogen carbonate. Why so many names? I don't know. Okay, it's called bicarbonate or hydrogen carbonate. The boy's name is Seung Yoon, right? Why is he? He was here in physics. Yeah. Can? Okay, so do you need to memorize all of these? Yes, but not today lah. You don't have to memorize everything in one day. You can slowly memorize them. Okay? Now, what you need to know is how to use it. So, for example, before we forget, remember the ones that I told you, the 7 good friends that are always double? H2, N2, O2, F2, Cl2, Br2, I2. Okay? When you write the formula, you must always write like this. Okay? Now, what do all of these have in common? Whether they are positive or negative, they are ions. Correct now? Whether positive or negative, they are all ions. So they form ionic compounds. Okay, so here like this, if it is, when teacher Jeff comes in, can you explain to him? Can you explain to him? Yeah, that he's not. Mhm. He was in physics just now. Then I saw him go toilet and I don't know where he went.
네, 피직스 배우고 지금 화장실 갔다가 똥손 빠는 화장실 안 갔어? 주방도 안 보는데 들어간 거 아니야?
All right. So like this, okay, now when it's MgCl2, when it's MgCl2, we just call it magnesium chloride. We don't need to call it any dichloride, trichloride, it's just magnesium chloride. Now, if it is if it is CO2, we call this carbon dioxide. So then you're going to be very confused. Teacher, why this one carbon dioxide, but this one just magnesium chloride? Why no need dichloride? So this one is a covalent or an ionic? CO2 is covalent or ionic? Covalent. Okay? So for covalent, we have to put di, tri, mono. Get it? So for example, if it's SO3, is this covalent or ionic? Covalent. How do I know it's covalent? Non-metal and non-metal. So this one I will call it sulfur trioxide. Okay? But for ionic, I cannot simply di, tri, nothing. Okay? However, if it's something like CuO, okay, now you look at this, in your brain, you must know Cu here is Cu2 plus, O here is O2 negative. It is not the same as Cu2O. In your brain, you must think, oh, if it's Cu2O, that means this Cu is 1 positive and this O is 2 negative. Get it? Can you see? Okay, so therefore, this one, because the Cu is 2 plus, this is called copper 2 oxide. And this one, because the Cu is plus, 1 plus, is called copper 1 oxide. Teacher, that means this one is magnesium 1 chloride. No, cannot. Group 1, group 2, group 3, don't simply put numbers. You only put numbers if it's transition metal that has more than one type. So can you see the difference between this type, and this type? Can you see the difference? Can? Okay. The only thing that makes this okay is practice. Okay. Just look at the sun. Past one is the first. You can refer to your periodic table, or you can refer. Do you want me to help you, or you want to try first? Want me to help you, or you want to try first? For task one. Okay. Now remember, this is silver. Okay. This is silver ion. And bromide is like this. When you're writing the answer, you cannot write this. You have to only write AGBR. This can be your working in your mind, but you cannot write it in the answer when they ask you for formula. So in the formula, this is your answer. Get it? You can write it down to practice, but in your answer next time in exam, the line you must only write this. Get it? Okay? Okay. Sodium carbonate. Okay, now this is one, this is two, right? This is one, this is two. This one, sodium is only one element. It's not two elements. So you just need to write Na2CO3 like that. Okay? Okay, potassium oxide K2O. Did you get it correct? Yeah. So this is iron 3 oxide. Fe3 plus O2 negative. So it's Fe2O3. All right. Chromium 3 chloride. So chromium is Cr. How do I know it's 3 positive? Because here they put 3. Get it? And chloride is Cl negative. So it's CrCl3. Okay. Okay. Okay, now this one's a little bit different. Okay, see this, calcium is 2 plus. Hydroxide is OH is 1 negative. But hydroxide is one element or two elements? Two. So you cannot just write CaOH2. Cannot. Cannot. You have to bracket to show that this two is this whole thing is double. Okay? Aluminium is 3 plus. Nitrate is NO3 1 negative. The number that you swap is the number on top, the 3 and the 1. This 3 cannot move. So it's Al bracket NO3 bracket 3. Get it? Okay, sodium sulfate. Okay? Okay. Good enough? Okay. Red to oxide PbO. Sodium phosphate. Zinc, this one need to bracket. Hydrogen carbonate, bracket 2. Ammonium is NH4, bracket 2SO4. Did you get it correct? Yeah. Okay. Gallium is 3 plus. Hydroxide is OH negative. So it's Ga bracket OH bracket 3. How do you find strontium? You look at the periodic table. So in the periodic table, strontium Sr is in group 2. So it's 2 plus. Selenite is selenium. It's in group 6. So it's just 2 plus 2 minus is SRSE. Okay? Radium is in group 2 also. Sulfate is SO4 2 negative. So it's RaSO4. And finally, sodium nitride. Nitrate. Don't get confused, huh? Nitride. So it's Na3N. Okay. Okay. No need to do all lah. You'll be sitting down here, I look at you, look at me, writing all this. But what I want to take note is, okay, for example, iodine. Okay, iodine. It's just I2. Don't forget that. But what about nickel? Nickel is Ni, just Ni, because it's just an element. Okay? Alright. Other things I want you to take note is, can you do this for me? Can you do just this part here? Here, the 1 until 8. Can you just do 1 until 8? And then 16. Can you do that? 1 until 8 and then do 16. Okay, I want to show you something.
What's sulfur gas?
Hmm?
I forgot the equation for sulfur gas.
Sulfur what?
Sulfur acid.
Okay. So sulfuric acid, the key acids, right? Nitric acid is a hydrogen with nitrate. Sulfuric is hydrogen with sulfate. And hydrochloric acid is hydrogen with chloride. So those are the three acids.
Okay.
You there? Okay. Okay. Okay, so lead 4, so it's Pb, so that's why you don't get confused, why lead 4 is PbO2, not lead 2? Because lead 4 means it's 4 plus, O2 negative, it cancel each other out. You get it? So like this, Pb4 plus, O2 negative, it becomes Pb2O4, then you simplify, is it? So formulas, you need to simplify. Copper, Cu, sodium, Na. Ammonium chloride, NH4Cl, ammonia, NH3. Okay, sulfur, right? Usually when we write in exam, we just write S. But sulfur actually exists as a molecule with 8, but you don't usually write it. But if ever you see the S8, don't get a panic. There's such a thing. It just means that sulfur is usually found as a ring, 8 sulfur, but we don't usually write in the equation. But if ever they give you S8, doesn't make a difference. It's still the same thing. Okay? So sulfuric acid is when you have sulfate ion. Okay, ion. Silica is actually known as silicon dioxide. Silicon 4 oxide, SiO2, that is silica. Okay. Silicon is just Si. This one, how do you do? This kind of questions, right, where it's non-metal and non-metal, you look at the valency. So hydrogen needs one more electron to achieve full outer shell. Sulfur needs how many? Sulfur is in group 6, it needs 2, right? So what you do is you do like that and then you swap. So it's H2S. Okay? Do you think you can finish the rest as homework? Can? Can Okay, not very difficult. So all you can take home and do. Okay? Very simple. Okay, so from formulas, now we go to the next one, which is equations. Let's look at the equation. Okay, like for example, like this. Look at page 95. Page 95. Like this. This is how you balance. So the number here, hydrogen and oxygen, hydrogen and chlorine, H2Cl2, that one we cannot change. We can only change the number in front. Okay, so here got 2, here got 2, we put 2 in front, and that's it. Okay, can you try and do 1 until 6? Just do 1 until 6. If there's no number in front, you don't need to write, don't write 0. You can write 1 or just leave it blank. Okay, can you try 1 until 6? Okay, ready? All right, now let's see. Can do this? So, 1 zinc, 2 oxygen, you put 2 here, then put 2 here. Can? Okay. Usually for your level, the balancing equation is only 2 and 3 and 1 like that. Not very, very big numbers. Once in a while, only when it's combustion of organic compound, it'll be very big numbers. Usually it's very small numbers. Okay? It's just a common, most common multiple and what's that called? LCM is what? Lowest common multiple. Usually it's just the lowest common multiple. Okay, so 2 to make it 6. 2 times 3 is 6. 2 times 3 is 6, and then here 2 aluminium. Alright, okay? Okay. Here needs 2 oxygen, so you put 2 in front. But now you have 4 sodium. Do you understand why you have 4 sodium? Yes? Do you understand why you have 4 sodium? Yes, because you need to multiply. Alright? Okay, last one. No, last two. Okay. So this one, 2 MgO, 2 Mg. This one is just 2 HCl. Is that all? Is that all I asked you to do? Okay, so later. Okay, you understand the concept? Get the concept? Okay. The paper I just gave you, can you look at the flip side of it? Okay. Can you try and balance A, B, C, D? This one. Okay. Do you have it? All right. Okay. So that's how I balance like that. Two, one, two. Okay. This one, how you do? Same concept. So four carbon, four carbon dioxide. 10, what are you looking at? Okay. 10 hydrogen, 5 water. Why? Because 5 times 2 is 10 hydrogen. Then only you count the oxygen at the back. Okay? 4 times 2 is 8. 8 plus 5 oxygen is how much? 13. So 13 over 2. Then what do you do? Times 2. 2. 13 over 2 times 2 is 2. Is 13. 8 and 10. Do you get it? Eh, Okay. Do you all understand? Okay. You okay? All right. So this one you might not be able to do it here. You might need to do it in your exercise book or somewhere empty because you have to write down the equation first. Okay, now don't forget what I taught you initially. Sodium is just an A. Oxygen is O2. And then you must find the correct formula for sodium oxide. Na2O. How do you know? You just learn it. And then only you balance it. Get it? Do you understand? Okay, do it the same for B, C, D. Then you get CaCl2 plus hydrogen. Balance the equation 2. Okay? Okay? Alright. Ammonia is NH3. Sulfuric acid is H2SO4. Ammonia is NH3. Ammonium is NH4 bracket 2SO4. 2. Can you see the difference? Yeah, okay. Minute break. Okay, so this part is very, very easy. Just need to see the numbers are just two. So like I showed you, your level, not to say it's very low, it's just that they don't have that many numbers. They don't go and put until 500, 6,000. No. It's usually between 1 to 10 only. Okay? Okay? Alright. Now, are you ready for us to go to the next level? The next level is calculation of something called moles. Okay, this one you go home, you want to do, you can do lah. It's not very difficult, okay? Uh, we will come back to it later lah. Now, next day we come and like practice again. Okay, we're going to do something called relative atomic mass. Okay, I would like you to turn to page. Okay, it's too small. Yeah. It's called relative mass. Yeah, here. I would like you to turn to a page 99. This page 99. Okay. So if you look at your periodic table, right? You look at your periodic table. Here they put the, can you see here they put the relative atomic mass? The number here is relative atomic mass. It's called a relative atomic mass because it is the average mass of the all the naturally existing isotopes as compared to which element in the periodic table? As compared to carbon 12. We talked about this already, right? So nitrogen is 14 as compared to carbon is 12. Silicon is 28 as compared to carbon is 12. Arsenic is 75 as compared to carbon is 12. So everybody, the relative atomic mass is compared to carbon 12. But now we have one more thing. We calculate relative molecular mass or relative formula mass. Okay, that means the mass of the whole thing. So for example, you look at page 100, the next page, okay? Calculate the relative formula mass. If it's an ionic compound, we call it relative formula mass. If it's a covalent, we call it relative molecular mass. Because ionic exists as compound, a giant lattice, but a covalent exists as a molecule. Okay? So basically, all you need to do is add it up together. So you see, PbCO3, right? The relative mass of lead is 207. The relative mass of carbon is 12. And the relative mass of oxygen is 16. Multiply 3. You don't simply go and multiply. So you add, then the last small number only you multiply 3. Okay? So you get 267. Correct? So this is called the relative formula mass of lead to carbonate. Okay? Okay? Simple, right? Okay. So these numbers that are given here are called the relative atomic mass. The relative atomic mass is the average mass of atoms on a scale where carbon 12 has a mass of exactly 12. Okay? Okay? Do you understand? All right. So, mm, okay, that's how you count. It's very simple, right? So if I if I want you to count like this one here, this is on page 98. Okay, can you see here? The formula is so weird. CuSO4. This is called a hydrated salt. It's not water. It's water molecules are formed together in a crystal. So CuSO4 dot 5H2O. Okay, how do you calculate the relative mass of this? Copper is 64. Sulfur is 32. This is 98. 98, the last word there. Oxygen is 16 times 4. Okay, now this dot, right, you add. But 5 H2O is 18. Hydrogen is 2 oxygen. Hydrogen is 1 times 2, oxygen is 16. So you take 5 multiply 18. Do you understand? So you get 250. Do you understand? Can see? Okay. Alright. Do you remember what are isotopes? Do you remember what's isotopes? And do you remember how to calculate the average of isotopes? Okay, that means the first one is how many percent, plus the second one how many percent, then we divide 100. Do you remember? Okay. So look at question 3 on page 100. Question 3 on page 100. This one, do you remember how to do it now? Question 3 on page 100. Do you remember how to do it?
Do we need to search it out or something?
No. Do you remember how to do this or not? Forgot how to do already. Okay, there's two kinds of isotopes. Boron 10 and boron 11. Okay? How what we do is if this is 50%, then this will be 50%. Then the relative mass will be 10 times 50% plus 11 times 50% over 100, and then we will get 10.5, right? Okay, if this happened to be 30%, then this would be 70%, correct? And then our calculations will be different again. Now, this question is telling us that when you add boron 11 and boron 10 together, your average mass is the relative mass is 10.8. So this is just algebra. How do I change it? Okay, so I'm looking for the percentage of abundance of boron 10. So let's say 10 is X percentage. If 10 is X, the percentage is X, then how much is 11?
100 calculated.
100 minus X. Use your iPad. iPad has a calculator. Your iPad has a calculator.
Yeah.
Over 100 equals to 10.8. Okay? So 10x plus 1100 minus 11x equals to 1080. X equals to Mm. Divided 20%. Okay. So that's how I know this one is 20% and the other one is 80%. Can you remember? Do you understand how to count this now? So this is the relative mass. Okay. All right. Now, another thing that we're going to learn is called a percentage of lead by mass. That means if I have carbon dioxide, how much is the percentage of carbon in carbon dioxide? If I have lead sulfide, how much is lead in lead sulfide? So this is how we calculate. How many lead do you see here? One. And one lead is 207, right? Okay. What is the total molar mass? 207 plus 32 times 100%. So 86.6. So 86.6 of PBS is PB. Can I understand? That's how you calculate this. So this is called calculating the relative mass. This is called the percentage, and this is called finding the percentage. Okay? Okay? It's not very difficult, right? So these are all very simple, simple math things. Okay? Okay. All right, now, can everybody turn to page 103? Okay. So this is the topic that students find the most challenging. How much is carbon? Carbon is just 12. But 12 what? There's no unit to it. Okay? There's no unit to it. So what happened is this guy, his name is Avogadro. Okay? This guy, his name is Avogadro, decided to count. So he counted and counted and counted into 6.02 times 10 to the power 23. That is his Avogadro's constant. Okay? So this Avogadro's constant means that whenever you got this many, do you know what is 10 to the power 23? That means it has 23 zeros. It's not a million, it's not a trillion, it's not a gazillion, it just goes on and on 23 zeros. When you have this many particles or this many atoms, the mass is equivalent to the molar mass. Okay, so let me explain to you. If I have sodium, it's just one sodium atom. But if I tell you I got 1 mole of sodium, it means I got 6.02 times 10 power 23 atoms of sodium. If I tell you I got 1 mole water, it means I got 6.02 times 10 power 23 molecules of water. If I tell you I got 1 mole sodium chloride, it means I have this many sodium chloride ions. Okay, basically it's like 1 dozen. If I tell you I got 1 dozen eggs, how many eggs do I have? 12. 1 dozen cars, 12 cars. So if I say 1 mole cars, 6.02 times 10 to the power 23 cars. That's a lot of cars. Can you understand? Can? Okay. So as long as I have that many mole, that mass is equivalent to molar mass. So for example, carbon is 12, has no meaning. Carbon is 12, has no meaning. But if I have 1 mole of carbon, now suddenly it is 12 grams. Got meaning already. So 1 mole of carbon, meaning 6.02 times 10 to the power of 23 carbon atoms is equivalent to 12 grams. Now suddenly there is a unit, suddenly there is a mass. So that is Avogadro's constant. That is the importance of Avogadro's constant. Putting making something that was relative, maybe something was just comparison into something real. Okay? Can you understand now? All right. So this gives us our first formula. If 1 mole of any substance is 6.02, if I give you the moles, can you help me find out what is the mass? Or if I give you the mass, can you find me the moles? So this is our most famous and favorite formula. Amount of moles is mass over molar mass. Okay, this is the most important formula of your life. Mass over molar mass, mass over molar mass. Okay. How long was COVID? COVID was 6 years ago, right? Yeah. When you were locked down, it was 6 years ago, right? Okay. 6 years ago, my daughter is now 10 years old. 6 years ago, she was 4 years old. So her kindergarten was online. Okay. So online kindergarten was only like 1, 2 hours like that. After that, the rest of the day, she just sat inside my study room and then sat with me while I was having lessons with my other classes. So I was having school lessons with my year 11. Okay.
What?
Year 11. Online class. Last time all online class during lockdown, right? Remember, COVID time lockdown. So I was having online class with them. And I had taught them the same formula. Amount of moles equals mass over molar mass. Amount of moles equals mass over molar mass. Then finally I was asking them, okay, guys, what we need to find the moles. What is the formula? Silence. All 12 of my students online was silence. So I started shouting at them. I said, I've been teaching you all so many times. I think my upstairs neighbor, my downstairs neighbor, my left and right neighbor also know amount of moles is mass over molar mass. I think even my dog knows amount of moles is mass over molar mass. I think if I ask my daughter who's 5 years old also she will know. So I looked at my daughter and said, hey, it's the formula of amount of moles. Then she just looked at me and said, mass over molar mass. So if my daughter at 4 years old, after listening to me scream for so many hours, knows what it is, I'm sure you also can tell me that amount of moles is mass over molar mass. Okay? Can? Alright, so it's very, very simple. Okay, how do we use it like this? Okay, like this. Okay, look at this page. Page 101. Okay? 101, define the term mole. So the amount of particles that equals to 6.02 times 10 to the power of 23. Okay, or you can say 1 mole of any substance is equivalent to its mass in grams. It's a relative atomic mass in grams. Okay, so the question says now I got 5.4 grams of water. How many number of moles? So write the formula because you will remember it for life. Number of moles is mass over molar mass. So mass is 5.4 grams. What is the amount of moles? Or what is the molar mass? Molar mass is relative mass. So 18. So 5.4 over 18, 0.3 mole. Can you understand? 0.3 mole. That's it. Okay? Got it? Alright. Let's do some questions on this. Dun, 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 dun. Okay. Can you do page 104? Just question 1. Just question 1. Page 104. Mm. Okay. Calculate the number of moles of. So number of moles. Again, I'm going to write it for the third time. Mass over molar mass. Okay, so in your dreams also you remember this, okay? So it's just 11.2 over 56. How many?
0.2.
0.2, and the unit for amount of moles is mol. Teacher, why didn't they just put mole? I don't know. Okay, that's how they write it.
So you sometimes put MOL.
No, like kilogram, kilogram is the word, the symbol is kg. Mole, mole is the word, the symbol is mol. Just this one E. I don't, it's not the one, I'm not the one who discovered it, okay? Alright, so we were, okay, can you try number three? Number three, what do you think it is? Yeah? So what's your answer? C lah. 1 mole, just equivalent to 6.02 Avo. So this number is called Avogadro's constant, and Avogadro's constant represents 1 mole. Okay, Avogadro's constant. Okay, can? All right. Try number four. Okay, number four. If you've done this, then we're going to do something else.
So it's just a constant that like.
That represents like a dozen. Like 1 mole is a
But it's not
dozen is
exact, right? It's not exact, right?
It's not 6.02, no, it's 6.02 something, 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 something. It's like pi.
But does it also like qualify for other like
No.
I mean particles like exactly?
Yes, everything's the same. All the particles, 1 mole of any one same weight. Was that your question? Was that your question? Is that what you asking? What do you mean? What do you mean? What did you mean by your question?
For
You don't know how to explain.
I when I saw the explanation
Yeah.
past function,
Uh-huh.
it's an average mass of atoms on a scale. It's
Yes.
not exactly for each atom.
No. That's 12. That's relative atomic mass. That's not Avogadro's constant. The average. Okay, so for example, this one, the relative mass of boron that we counted just now was 10.8, right? This one, this boron is 10.8, right?
Yeah.
So this means the average mass of boron 10 and boron 11 gives us 10.8.
Yeah.
So the relative atomic mass is the average mass of all the naturally existing isotopes.
Yeah.
That's what this is. This has nothing. The relative mass is already averaged out. So that's what we're
So
calculating. Yeah.
if you just divide, I mean,
But those are two separate things. That one I'm counting the relative mass of in the periodic table. This is a question I'm asking you to calculate particles. It's not the same thing. You
I'm
understand?
not talking about.
What are you talking about?
I don't.
Okay, never mind. I think too many. You go back and try. You go back and think about it first later. Then you think about it slowly. Okay, this one, what did you get? A. Do you know what did you get?
Okay,
Okay, how did you calculate?
just add.
Okay, ammonia gas is NH3. So how many atoms are in that? NH3 got how many atoms? No. NH3, this one molecule got how many atoms? 4, right? And then I'm looking for 2 more. So times 2. So 2 times 4 is 8. Then 8 times Avogadro's constant. So isn't it C? Get it? Can I say? You look at this speech. Each one, each person take one. Oh, sorry. Okay, you understand this question? You understand why is it C? You get it? Because they're asking you how many atoms in ammonia gas, in 2 moles of ammonia gas. All right. Can you please look at this paper that I just printed out for you? Okay. Can you just try and do question 1? You can look at your periodic table. Just try and do question 1. Right? The paper that I just gave you, task 8, question 1. Okay. So A is 72 over 24, correct? B moles. Now, when you calculate, everything has to be in gram because molar mass is in gram. So 4,000. CuO is 64 plus 16 is 80, right? So 4,000 over 80, you get 50 more. Okay? All right. How much was the molar mass of aluminum hydroxide? 27 plus 16 plus 1 times 3. Correct, right? 17 times 3 plus 27. So you get 78. Did you get that? So your amount of moles is 39 over 78 equals to 0.5 kg. Correct? Do you understand how to count? Can you see? Okay, last one. 1 ton is 1 million grams. 1 ton is 1 million, 10 to the power 6. Okay? NaCl is how much? 23 plus 35.5. So you get 58.5. Alright? Finally, milli is how much? 10 to the power of negative 0.
It's like
Negative 3.
0.00.
Yeah, 0.00. Because milli is 10 to the power negative 3. Micro is 10 to the power negative 6. You all know that, right? Okay, so mass over, how much is CuNO3? Oh my goodness, how to count?
188.
188, correct. Do you know how to count? This whole thing, you must times 2 plus 64. Okay, and then you can press calculator yourself. Do you understand? Can count? Okay. All right. That's all for today. Okay. Huh?